Hello, everyone. Just going to give everyone a moment to log in and then we'll get started. All right. Good morning, good afternoon, wherever you guys are joining us from today. Welcome to today's webinar, co-hosted by the New York Oracle User Group and Oracle partner Viscosity North America. We've got a great presentation for you today. Oracle ace Michael Rosenblum is presenting for us, and we're very thankful and excited to have him here. This is a live webinar, so feel free to submit questions in the Q&A field, and Michael will get to your questions as he can. If he doesn't get to them throughout the webinar, he will try to get to as many as he can afterwards. Okay. All right. Again, co-hosted by Viscosity and NYOUG. This is a live and recorded webinar, so don't worry if you've got to go back to a recording later for any pieces of information, or if you have to drop early, you will have access to that, as well as any other resources that Michael decides to share with us. My name is Monica, and I am the marketing director here at Viscosity. Co-hosting with me are NYOUG board members Coleman Leviter and Rob Edwards. Coleman's going to tell us a little bit about NYOUG. Then I will tell you a little bit about Viscosity, and we'll get started.
Thank you so much, Monica. So the New York Oracle Users Group was formed in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products. Next slide, please. So you can connect with us on nyoug.org, Facebook, LinkedIn, meetups, and you can email us directly for any questions. And of course, you can go through our website and see the past presentations that we've been doing for the past 5 years with Viscosity as co-host. So I want to thank Viscosity again and for making this series of webinars possible. And back to you, Monica.
Thank you, Coleman. Yep. So again, my name is Monica, marketing director here at Viscosity. Hopefully some of you guys have seen me out at different events and conferences throughout the US. We are a full Oracle stack consulting firm where our mission is to enable businesses at a time when companies must change to survive. And our core expertise is built upon these three pillars you see here: data, apps, and cloud or infrastructure. So if anything throughout any of these tiers speaks to you, any pain points you've got, anything, just like questions you have. Our team is fully based on Oracle technologies and more. So feel free to let us know if we can help you in any way. I'd be more than happy to chat with you. Across the bottom, you'll just see a bunch of different things we offer to all three tiers. So it could be assessments and workshops, could be POCs, maybe you just need managed services, or maybe your team just needs some extra training, maybe some development for new hires, things like that. So a lot of our folks are very used to giving training classes to both big public audiences like this, but also tuning it down to very specific training needs that you and your organization may need. So we can custom fit things to you here. Right, these are some of the books that my colleagues have written. So this is just a couple of, I think we're at like 35 or so total books. So yeah, some of these are going to be updated hopefully by the end of this year, but we'll see. We normally give away a bunch of new books at Oracle Cloud World. So if that's the case, I hope you can come find us there, and we do book signings. And then these are some of our guys that you probably see either on webinars like this or out at conferences, or maybe you own some of their books. So they are part of the Oracle ACE program, and it is something that they are all very proud to be a part of. They very much dedicate their time to knowledge share, just like Michael, our speaker today, helping the Oracle community to thrive and learn. And it's really a great program. If you're not familiar with the Oracle ACE program, it is titles designated to people who do not work for Oracle but are out there continuing education for users like you all. Okay, and like I said, today's webinar is recorded. Viscosity uploads all of our recordings to aurapub.com. It is our training platform, also created by a Oracle ACE director. AuraPub is part of the Viscosity family now, and we love it. And we host regular training there, live training, and you can go check them out. Those are at a fee, but there are tons of free resources here. So if you just sign up as a free customer to AuraPub, you'll have access to tons of recordings and more. And you'll also be able to see different tiers of membership we have there, which I always recommend to people. Ask your company if they would be willing to reimburse you for it because it's great training, and you do get some extra perks with the other membership tiers. So check it out. And then I do want to point out that Viscosity will be at Kscope this summer. It is an Oracle user group, nationwide user group conference. Michael will be there as well speaking. I'll be there at a booth with my team. It's my team that's going to be speaking there will cover both the database or emerging technology track as well as the Oracle Apex track. So definitely come out. It's one of my most favorite conferences. So it's here in Dallas. I'm in the Dallas area, so it's here at Grapevine, which is next to the Dallas airport. So definitely come check it out. Let me know if you have any questions about Kscope. I've been going for a long time, and you can also get $100 off your registration with this promo code here. All right. Awesome. And then for any other upcoming events, I know we've got everything I think built out for NYOUG and Viscosity through June. And I think we are about to add more for July, August, and September. So definitely take a look. Hopefully you're getting those NYOUG emails as well. And don't forget, you can also sign up through nyoug.org. So with that, just a couple reminders again, this is being recorded. You'll have access to this recording and a slide deck or anything else that Michael wants to share with you today through nyoug.org and through aurapub.com. So with that, I'm going to let Coleman introduce our speaker and let Michael get his slides up.
Thank you, Monica. So Michael is a software architect development DBA at Delcian, where he's responsible for system tuning and application architecture. Michael supports Delcian developers by writing complex PL SQL routines and researching new features. He is the co-author of PL SQL for Dummies, PL SQL performance tuning tips and techniques, contributing author of expert PL SQL practices, and author of multiple database-related articles and conference papers. Michael's an Oracle ACE, a frequent presenter at various Oracle user group conferences, Oracle Open World, ODTUG, IOUG, RMUG, and NYOUG. And we want to thank everybody for coming to this webinar today. And without any further ado, Michael, please present the webinar.
Hello, everybody. Thanks a lot, Coleman, for the introduction. I really appreciate NYOUG community for the service that it provides to the whole IT industry. It's been years and years that I've been involved because if I correctly remember, my first NYOUG presentation was in 2002. So it was quite a significant period of time that I've been part of this community, and I'm really glad that this community is alive, that this community is active, and this community continues to share the information in our area, in our pretty technology-centric part of the United States. So let's get to the topic. I've been talking about various mechanisms of how you can build queries on the fly for quite a while, and I decided to make a single presentation that talks about different ways of how you would construct SQL, why, and for what reasons. That's what we will be talking today, and let's get to the presentation. So a bit more about myself, but that's pretty much was covered. I've been doing books for a while. Recently, I got tired of writing books, so I've been more in the last couple of years as involved as a technical editor for multiple communities and for multiple publishers. So it's still entertaining, and books are still important part of the learning, and kind of more towards the reason of why I show you the slides. I've been doing for more than 20 something years database development. That's my bread and butter. That's something that I've been doing for all of this time. And the areas that I've been mostly involved is complex functionality involving code generators and various repository-based development. Because if you've heard about Dalcian, about Brim engine, about our repository manager, we are heavily repository-centric platform. Like, for example, in one of our largest projects, the percent of code generation is 98. So we have only 2% of our code base written manually. Everything else is either generated real objects or generated on the fly. So that tells you that I've been pushing all of possible permutations of what you can do with dynamic SQL construction for quite a while. And I've been for also quite a while, constantly communicating with Oracle PL/SQL team, and I've been involved as an Oracle ace with internal hearings. So kind of I've been in the industry for quite a while. So as a result, I have a lot of stories to share. And also, kind of another part, I've been working in the same company at Dalcian since February 2001. So as a result, I have a lot of continuous stories. So it's not like I am a consultant who jumps from one project to another, to another, to another. I am building systems and I'm maintaining those systems that I build. So as a result, I have experience that gives me something that not a lot of people have. I know whether long-term effect of solution was good or bad. And this long-term, because some ideas or some decisions may be working perfectly now, but eventually things may not be as good as you initially thought. And you eventually may recognize that this decision may have not been the best option you ever thought for. So this is just kind of to give you a bit of a broad picture, and also about broad picture, as you can guess, listening to me, that I had not been born on this side of Atlantic Ocean. I'm originally from Ukraine, and considering that I moved to United States when I was 20, 22-year old, so I could not beat my accent, so I apologize for it in advance, and I will try to speak and articulate everything as clearly as possible, but just in case I want to apologize for it. Okay, so let's start talking. Okay, why bother? This is the question everybody asks when people are talking about dynamic mechanisms of constructing SQL on the fly. SQL is extremely powerful tool, and it becomes more and more powerful and potent with every version of Oracle. There is obviously model clause, there are macros, there are things that SQL is constantly being expanded to, and more of those functionality. And another thing that obviously you write a query, it's you articulate what you want. You don't usually, unless you push a lot of hints, you don't tell Oracle exactly what to do, so you have the whole layer of optimization and cost-based optimizer. A lot of people think that it's as close to artificial intelligence as you can get. It's pretty much semi-sentient. And it's interesting how it develops and solves more and more for you. And I've been talking to Oracle people. One of the feedbacks I've got that it's easier for them to fix the engine than to teach developers to write good code. I apologize, but that's true. That really sometimes it's easier to adjust things on the internal side than to expect people to write something from the first try that would make reasonable effect and it would be a good quality code. Okay, so why bother? Here is why bother. Because your code may be perfect, but users don't always know what they want. Well, until they really want. And user cannot tell you what they will want. So you need to somehow build systems that are future proof, or at least somewhat adjustable, that it should not be carved in stone. It should be possible to change it afterwards when users recognize. And there is a worst part of it, that kind of if everybody was involved in development, there were cases like this. Users sometimes forgot to mention you some things, and there are things that they really know, or they really assume, or they just don't know what happened. So there is this layer of unknowns in every living system, and that's where your volatility kicks in. And another layer, sometimes you just really hit the problem where SQL is limited. And you can either go to procedural solution, or you can extend SQL in one way or another. For example, you can make custom aggregate functions, and I will show you example today, or you can transform SQL via SQL macros working with the text. So there are things that really could be changing because of the real requirements. Okay. And another thing, there is a pure tuning potential in transforming SQL on the fly, because, for example, instead of optimizing one meta query, you could cut it in chunks and optimize smaller ones. It will be easier task for Oracle to solve a couple of smaller problems rather than one bigger problem. Another thing is, for example, you have cases where you may or may not have access to the data sources, and they are of questionable reliability. This is, I don't have this example in this presentation, but I had a real case where I would, in the real system, retrieve data via DB-Link that sometimes was up, sometimes was down. And recompiling an object when link was down would cause a lot of problems because it could not validate that the structure is correct. So I converted calls in dynamic SQL and completely avoided hard link. That's another reason why sometimes you may step into dynamic code for other reasons, or there may be a sad reason of cost-based optimizer issues. Like there is a well-known 11G, I would not call it a bug, but optimization problem involved predicate push into inline views. In 11G, it's known, it's fixed in higher versions, but it surfaces from time to time if you need to support older versions of the database. And the only way to resolve it is to convert your code into dynamic SQL. So there are different reasons, both functional and structural, and all of them lead to the point that you need to know how to step from explicitly coded SQL into something else. And here I wanted to show you a real use case. This is a story from another one of our long-term projects that was made for one of New York State agencies. Okay, here is a simple story. Day one. People wanted a pretty simple screen. Kind of, there were a couple of users. They wanted a simple screen to look up data, just few parameters, and they wanted to work really. They wanted it to work really fast. Okay, we tossed it to one of our junior developers. It was pretty simple screen to write. Quickly, a couple of days later, it was in production. So, okay, everybody is happy. Day two. Okay, everybody is happy. Day two happens about 2 years later. We received additional requirements. This screen is being used by pretty much, I would say 10 to 15% of users. They want a couple more search criteria because they want this and want that, but it's still pretty simple. The same junior developer picks up old code, okay, extends it a bit more. Database still can handle it. Okay, it's still reasonably functional. Now, another couple of years pass, and we receive suddenly a request with a huge expansion of that search screen, because it appears to be that after a couple of internal mergers, this module is being used by about 2/3 of the whole company, of the whole agency, and eventually logics become huge. And now senior developer who was years ago a junior developer looks at the query, sees, wow, it's a lot of table involved, and database starts to panic because now we are getting into this huge spaghetti code with, I think it was about 25 tables involved. It was became unmanageable. So this is the real story. Kind of simple search, expanded to larger search, expanded to something at the bottom, and this is a real screenshot from at the bottom of the event finder that everybody was using. This is a real story that spanned about 5 years. And here, that's what I call working SQL curse. If you have powerful functionality, sometimes good SQL mutates into spaghetti SQL. And this is what I mean by spaghetti SQL. It's a single complex one that eventually takes all possible problems. And what you get is the following. Why I call it a curse? Some conditional permutations cause performance issues. So as a result, you can fix it for the case A, but it worsens case B. You go work hard, fix a case B, it creates problem in the case C. So you constantly try to fix for somebody that breaks something else. So aftermath is eventually you fall apart or the whole system falls apart, or you come up with solutions that makes it perfect for maybe 15% of users and creates a performance hell for the other 85. So it becomes eventually unmaintainable. And really, this Uber SQL applicability really has two parts. I can accept it for case number one, where you know all involved structural elements at the design time. And here I want to highlight know and design. In this case, complex sequels are just fine because you have additional tuning mechanism, you have predicate analysis, you have histograms, you have lots, and you have baselines, you have a lot of pure SQL tuning techniques. And it really happens in large warehouse and processing environments where you use millions of rows or billions of rows. It sometimes in complex reporting it real happens, but these are the cases where standard DBA solutions work. But if you don't know everything until the runtime, that's where complex sequels may temporarily solve your problem, but will always cause problems in the long run. For example, and my classical example is this generic search screens or flexible reporting modules. You don't know all of the involved elements until the runtime, and that's your breaking point. So I want to really clearly articulate this is the difference between, at least for myself and how I analyze functionality. Do you write SQL or do you write SQL constructor? Design time, you either know all of the pieces or you don't know. And this is a very clear trigger that allows you to make systems be future proof. Okay, and here my proposal for this type of SQL solutions is to replace SQL with PL/SQL user-defined functions that takes all of the input parameters, constructs SQL on the fly. Inside of it, you control the process flow. That's what I told you previously. You split one action into multiple ones if needed. You involve only required data elements. You short circuit if necessary. So you have full procedural control, and then you return the result as as object collection. So with using of this functionality, now you have a way out. Okay, key trade-off. It's a single technology, SQL, to multiple ones. It's SQL and PL/SQL. So obviously you have corresponding bugs, issues, learning curve. Another part is logical flexibility versus power of native SQL tuning mechanism. Because as I told you, cost-based optimizer becomes better and better, and on different versions, you have this point of splitting to, okay, the SQL cannot be maintained by Oracle, may be different. And obviously, you have more of the platforms, more of the areas, higher probability of human areas. And another thing that kind of as a big business rule fan, I want to warn you about rule proliferation. Because previously you had one SQL statement, now you have more complex code, maybe multiple modules that would create rule inconsistency. So this is just a warning that, as always, good things come with a price that you pay for. Okay, and on the other side, advantages, it's flexibility and isolation of UI logic. Because if you create a function with parameters, it's pretty much an API. You can change everything inside, deploy, and nobody in the front end will ever bother, would ever notice it. And on the other side, disadvantages, advanced coding techniques, so it's more testing, and object types, obviously, more careful with the memory. You don't want to load millions of objects in your PGA because bad things start to happen, especially if you have multiple sessions. Okay, and another thing, scary dynamic SQL. This is something that a lot of people are afraid of nowadays, but I want to tell you, with right utilization, it's not as scary and it's not as risky as current news makers make you think. So just a couple of slides here on dynamic SQL because it's one of my favorite tools, obviously, and really I wanted to share with you a couple of examples of how you make it safe. Okay, basic trivia. It's a very powerful, it has to be handled with care. It can solve a lot of problems. Also, it can create a lot of problems if mishandled. And there is no good reason to make it a database boogeyman. You need to be careful, and as a result, you may want to make sure, and you can tell your managers that no, they will not appear on front pages of New York Times if you handle it appropriately. And it's pretty straightforward. There are only a couple of things you need to remember. User input is allowed to define logic. For example, if city is passed use table address and be used as bind variables of matching data types. This is another critical thing because implicit data type transformations could be used as backdoors. And in rare, and this is the third point, here is where it has to be vetted and carefully tested. When user input can become part of execution code, it has to be validated using DBMS assert APIs. It's really powerful Oracle package that allows you to secure those rare cases where user input can become executed code. But otherwise, if you use it as bind variables of proper data types, it's just technically impossible to have code injections. And one thing is critical, user input is never should be allowed to directly become part of executed code. Never concatenated. So it's either placed with a logic, it's bind variables, or very tightly controlled with via DBMS assert. So this is just to make sure that we are on the same page. Okay, and here let me show you real code how to do it right, at least in my understanding of database development. Okay, you always start from the end. You start from what you want to receive for it. So for example, here we do search on emp dep example, and I want to receive employee number, employee display, and compensation number. This is my output type, and I build an output collection also. So not just simple object, it's also object collection. Then I build a function that takes all of my possible parameters, employee number, name, location, and limit of how many rows do I want to receive. Because obviously with object collections, you want to limit your output to make sure that you're not trying to bring millions and millions of rows. Okay, I also start from my output. Here is my output type that defines itself as a collection and constructor. So we have initialized collection, so it will be at least something. It's an object type, so it needs to have a constructor. Okay. Also, a couple more variables. I have from blocks that I will be constructing, where blocks that I will be constructing, and total PL/SQL code that I will be constructing. And it's interesting because this is one of my personal know-hows that I've been sharing for all of the years. It's much more efficient for generic search to construct PL/SQL than to construct SQL. Because as everybody who touched dynamic SQL knows, if you define two bind variables, you need to pass two parameters. If you define three bind variables, you need to pass three parameters. Here, I don't know how many of the parameters will be populated by users. So either I need to build a lot of constructs with a lot of all possible permutations, or I can go with PL/SQL. And let me show how. Okay, so this is my straightforward logic of how I'm building elements. If employee number is specified, I will add to the where clause additional reference to employee, and here I will reference PL/SQL variables that will hold employee number. If ename was specified, here I add extra element, and I apologize for code consistency. I removed DBMS assert here. This one should have been wrapped into DBMS assert. If location is not null, then I do extra join here. And here is a join where it's important to know ANSI SQL, because it's much easier with ANSI SQL to separate where clauses and join clauses. It becomes more readable. Okay, and here is why I want to do PL/SQL, because I can declare variables of all possible binds. I can declare, if it's 10 parameters, I can declare 10 parameters. If it's 15 parameters, I can declare 15 parameters. And the default values are my bind variables. So I will always have the same, if let's say 10 parameters, I will have 10 in values. If I have 15 parameters, I have 15 values. I don't care how many of them are populated. Only some of them will be used inside. And here I construct variables. Here I construct SQL statement where my output is an object constructor. Remember, I'm not returning record. I'm returning object. And this is my output. I do bulk collect here into this output variable. So this is my execute immediate that takes all possible parameters and throws out object collection with the result. And another kind of practical experience, if you're using dynamic SQL, just quick reminder, it's useful to do DBMS outputs to make sure that what you fired is really what you think should have been fired here. It's really useful to do those checks. Now let's take a look how it works. And here are some of the repeated elements, if you will be reading those slides afterwards. The table depth, and this is the key element. Depth is joined only when needed. This is the major performance booster for those complex search queries. You analyze parameters, and in your SQL, you use only tables that really are important. This is critical. And another thing, you build PL/SQL block to simplify passing bind variables. And the last thing, just to remind, that you build a constructor, not the record. And let's take a look how it works. Okay, how you query it, it's pretty straightforward. You have table clause that pretty much everybody who worked with object collection already know, that converts object collection set into SQL set. So attributes become columns, and it become pretty much your empno DSP, and compensation NR attributes become columns. That's the result of the query where I passed employee ID. And this is my SQL statement that I've built. I constructed this query on the fly. And as you can see, there is no depth table here since it's not needed in the output. It's needed only in the search. Here is example 1. Here is an example 2, where I pass multiple parameters and limit 2 rows. This is my output. And here is my query. Now we have extra join and extra condition. It's much more readable to construct, in this case, ANSI SQL, because you immediately see what's going on. And another thing, here in name, it becomes a part of the construction. It's pretty straightforward, but you still pass only bind variables. It's code injection proof because those bind variables will go here. They don't impact anything else. I change structural elements on the fly. Okay, this is basic example. And now let's take it on the next level. Hard-coded fetch limit is pretty much not user-friendly. You never know how many times people would click next, 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 next. The simple solution is, and this is kind of one of the real projects, instead of fetching everything, I can return ref cursor for the object collection and let somebody else figure out how much they need. Here is an example. So I have the same function with the same parameters, but instead of returning object collection, I return sysref cursor. So I declare a variable sysref cursor. Everything else goes the same. And here is a difference. Instead of selecting data set or selecting object constructor, I am just doing open ref cursor for. And as you can see here, I don't even need object type since I'm returning simple SQL set. What's funny, even now, even we return it as technically an output that we can return further down. Just remember that for dynamic SQL, ref cursors are in parameters. Just remember, there is no clear reasoning for why it's this way. That's how it should be coded. And here is an example. I fire a function with search for the Smith, return ref cursor, and then I can do whatever I want with this parameter. It allows you to flexibly build your query, pass it to, for example, to middle tier, and let them handle whatever they need, how many times they want to click next. Okay. Another level up. Users nowadays are spoiled. They want to get the data as fast as possible and as now as possible. So Oracle provides you a mechanism to quickly return first some number of rows, first elements, while calculating everything else, while results are being calculated via pipelined functions. It's pretty complex functionality, but still it is doable. Let me show you an example that mixes approach of getting object type and ref cursor. Okay, so I have function that takes the same parameters, page size, how much do we want to quickly return? We return object collection since we want to receive a query set, and there is extra parameter pipeline. Please be aware that this is how you define pipeline functions. Now in the variables, I have both ref cursor and my output type that I will be returning. Here how it works. Step 1, I build a ref cursor constructor that returns object type. So now I'm returning object type as a set because that's what I will be piping out. But still, step one, I construct a SQL statement on the fly, fire it. Now I have ref cursor pointing to my set. And then I start fetching this ref cursor limiting for how many pages I want. And when I retrieve the page, so I don't do it row by row, I spin through this collection and do pipe row out. This is a pipeline functionality that throws it out. So as a result, now I spin through, I pipe out first page, then retrieve next page, pipe out page, and so on, and so on, and so on. And then eventually I close ref cursor and exit this function. That's how you can do pipeline functionality for the environments that allow you to retrieve first rows while everything else is being cooked by the database in the middle tier. That's how you can do that. Okay, so let me give you a bit of a query construction review. With the combination of SQL and PL SQL, you can build anything by using corresponding advanced techniques. It's not cheap and simple. Sorry, I want to reiterate. Yes, it requires a learning curve and it requires being very careful. But you can make your system better for everybody. And you can get out of that loop of fixing for the logistics that break for finance, fixing for finance, break for accounting, and so on, and so on, and so on. You cannot make everybody happy with huge single SQL statement. You can make everybody happy with this approach where you fine-tune everybody's request. That's how you make it different. Okay, that's about dynamic SQL. Now I wanted to talk a bit about one of the new and shiny toys, SQL macros. It's a very interesting concept. Key thing here that macros are processed at hard parse time. And I want to highlight it. I don't know, maybe in the next version of the presentation, I will make double the size of the font. It's hard parse time, not the execution, not soft parse. So the initial parse time, that's where macros are processed. They are reusable elements of SQL code that can be shared across the system. So the idea is it's just a text to be resolved. So as a result, you don't pay context switch price. They were introduced in 20C that really never went to real environments other than being in the cloud. And as a result, it was ported to 19.6 onwards, but only table variation. And that allows changes in the from clause. The scalar variation of macros only exist obviously in 21 and onward, allow you to change pretty much everything else. Just direct quote, they can be used wherever PL SQL functions are allowed, for example, in the select list, the where clause, the order by clause. So scalars, everything else, table is only from clause. Okay, so basic example. You can, for example, if you have standard military time printout, you can make it instead of a function that would convert it, you can build a text that takes a date and converts to this type of a format. And then if you use select military time sysdate from dual, you receive the result. But what's interesting, this is not a real function. You see this extra clause, SQL macro scalar. What happens? First time this military time is referenced, the text in quotes is being inserted here, and that's what is being executed, and parameters are successfully passed inside. This is nothing more and nothing less than text. So for example, if you would reference a real function here, you would not see it in dependencies. And that's what I don't like macroses, it's a really cool way of hiding business rules. It's not parsable, pretty much, I'm sorry, as dynamic SQL, but it's another way to hide business rules. Okay, then let's take it further down. I will try scalar function on complex condition. Here it allows you to pass a list of functions. So pretty much I'm passing a table or one of the columns. There is some really interesting functionality. You can spend a couple hours on the macros. So here it allows you to pass inside of the macros column names and column structures and the value. So for example, here, what I want to evaluate value and to add or not to add condition. Like for example, if value is passed, add the where clause. If value is not passed, return null or 1 equal to 1. So just skip it on the text level. And initially, okay, I fire it for the employee number. It returns me Smith. I fire it null. It returns me everybody, because I really hate when I see in complex SQLs this type of statements where emp_no is whatever is being passed or whatever is passed is null. It seems on the initial try, or you see here practical examples, that it may work. What's unfortunate, it doesn't. Because as I told you, it's being macroses are evaluated at hard parse time. So if I will run the same code, but inside of PL SQL, you see, I run function, I have a value and pass the value inside via variable, I receive total count. It ignored my where clause. That's the scary part of macroses, depending on how you run it and at what point hard parses happen, they provide different results. So you see, just one more time, let me articulate it very clearly. I have a variable to which I assign the value. This variable is being passed inside of macros. When I run this PL SQL, Oracle doesn't know what will be the value of this variable. So at the hard parse time, this value is null. And as a result, macros is being evaluated. Let me step back. It goes 1 equal to 1. It doesn't know what the value is. So this is a dangerous part about macros. And okay, here let's go to table macroses that are a bit more available since a lot of people are in 19C. It allows changing anything in the from clause, and it's somewhat conditional since it's evaluated at the hard parse, and I will show you a couple of examples. But on the other side, it's polymorphic but not dynamic. You cannot control moment of evaluation. And that's why I still think that dynamic SQL in a lot of cases is more preferable unless you really hit perfect case for the macroses. And another thing, there are a lot of small prints here. Macroses even between versions of 19 are constantly being changed. And especially kind of if you talk about 23, they always add something more. It's functionality in progress. There are behavior changes that were reported. Let me show you an example. Okay, here I want to change using SQL table macro. I want to evaluate what are my parameters. I want to see whether I can access it so I can change my logic. Okay, I put 3 parameters, number, date, and text. And even in 23 AI, only numeric parameter is accessible within the macro. I can do dbms output. They perfectly process it, but for some reasons, they don't show you what is the value. So that's kind of an example of the system being work in progress. Okay, now let's try more real example and show you all kind of a bit of the confusion, but on the other side, a bit of the powerful elements of why SQL macros are important and why it's cool to be polymorphic. Okay, here is an example. I'm trying using polymorphic function to simulate my search. I pass employee number, department number, and limit. Okay, and if department number is being passed, my output, and here I construct basic one, 1, 2, 3, 4 columns. So this is one output. And if it's not passed, my output is 1, 2, 3 columns. So like, as you remember in my dynamic SQL example, there I have always the same object type as output, irrelevant of how many things I populate there. Here, I change the nature of my output, and let's take a look at the example. I run search where I don't populate department, and my output has 3 columns. I run search where I populate department number. Now I have 4 columns. So that's really an illustration of polymorphic nature of macros. You really can change what you're returning, how many columns returning, what kind of columns returning. You can change everything there. So it's extremely powerful, but the problem is I still want to illustrate that it's evaluated at the hard parse. The same example, department 10, department 20, department 30, but within the PL SQL, call number 1, call number 2, call number 3, return the same results, full table scan. Because as I wanted to reiterate, evaluation of this parameter happens, of this parameter, department number, this parameter, happens at the parse time. And at the parse time, those values are not yet specified. But if I will hard code 10, 20, and 30, it's 3 different cases that they will be evaluated at the parse time. And now I have 3, 5, and 6. So this is a very clear example. I want to remember that you cannot directly substitute dynamic SQL with macros because of this nature, because of the nature of hard parsing. Okay, a bit of a review. Yes, macros allow you to make chunks of your code reusable within SQL. And it allows you making it polymorphic with different environments and with different results and with different processes. But is not as flexible as PL SQL user-defined functions, because PL SQL user-defined functions are processed at the runtime exactly when they happen and parsed exactly on the spot. So you have much more flexibility of changing your code and the business logic. And another thing in macros is still work in progress. I want to very clearly mention that there are constantly posted issues, posted elements, posted small prints, even between micro versions. And to answer the question, this presentation and video will be available in multiple locations at OraPub, at New York Oracle User Group website. So yes, it will be available. You will be able to get everything. And by the way, one of the reasons of why I wanted to highlight all of these things, that's why there is no live demos. All of the code snippets are directly embedded into the presentation. Okay. A bit less of the doom and gloom. Now, really rare but fun functionality at the end. Creating your own aggregate functions in Oracle is possible. It's confusing. It takes a couple of, politely saying, couple of tries, but it's still doable. Let me give you an example, and this is one of my favorite ones. Even in 23 AI, list egg is limited to 4,000 characters. I personally hate it. I really, really think that Oracle eventually should have made it multiple versions that could return CLab. But even in kind of nice fun part is that they fixed it a bit. I think if I correctly remember, starting 21, they have a parameter that allows you to say what happens if it's more than 4,000 characters. You want your code to blow up, you want the code to return dot or something like this. Still, they didn't come up with new functions that would return more than 4,000 characters. Well, I'm sorry. This is real life, and people really need sometimes to concatenate a lot of elements. I, for years, have been using it in a lot of my environments. Yes, it's a bit scary, it's a bit confusing, but it can get you out of the corner. Here is an example. And list tag, what another interesting thing, all aggregate functions except list tag take one parameter. List tag takes two, what column you want to build and what is a separator. So obviously, if I want to simulate it, I need to have my own type as an output with values that I want to concatenate and separator that I want to provide. Unfortunately, I will have to repeat it in every type, but this is the nature of it. You can make it a global variable or fixed separator. Here is just one of the examples. Okay, and then fun starts. Fun is because of the nature of ODCI object types. So for the function, you need to build a very specific type as an implementation of this function that contains fixed named elements that have to be included with exactly the spelling of it. So what I want an object that contains syllab as my output, default separator, just in case nothing provided, and then initialize, iterate, terminate, and merge functions. Here are all of the elements that I want to include, just if you will be reading it. Initialize sets up, iterate spins through values, terminate collects multiple groups, and merge, if you run in parallel, allows you to put together parallel threads. Here is the logic. Okay, initialize default constructor, well, null and separate comma if you passed it. Terminate, pretty much return your object attribute as itself. Here is your real functionality. You spin through and you write append, write append, write append. You add values to your output with separators. It's pretty straightforward. You spin through it until it's needed and merges in pairs. That's how it's internally being fired. It kind of, if there would be multiple threads, Oracle would fire it in pairs. So you do dbms lob append, you put together multiple parallel processes. So pretty understandable with all of the very explicit references to corresponding Oracle types and named variables. So it's kind of, it's easier to take one of those code snippets as an example and get through. Okay, and here some of the key points you can read. So it's pretty much your output as a formal result. It merges attributes and sets up everything as a single creature. And as a result, it's pretty easy. That's what you publish. You create a function that takes your object types as input. It returns clob. If you have parallel enable, aggregate using your object type. And so that's really what everything needs to see, because the usage is this. You pass in the constructor ename and comma if you want to use it as a separator. So that's how you override requirement of Oracle that aggregate functions can take only one parameter. It is one parameter, it's just object type. So I work around this, and here are my outputs, my normal list arg that returns clob. So this is an example of how you can really make it operational. Yes, it's a bit crazy. Yes, it's doable. No, it's not for everyday solution, but sometimes really that was a use case that I needed to handle in the number of environments. Okay, And here is an example that I can use it even as analytical function. So it becomes fully operational Oracle module, as you can see. Okay, so aggregate functions are fun. You can do it if needed. It's not for everyday use because it's pretty resource intense and complex in nature, but it is possible to do. Oh, it's already 1 o'clock and we are perfectly on time. So overall summary, that's I want to first of all thank everybody for attending, and I really appreciate your need and your understanding of the importance of constant learning. And I really hope that this presentation gave you something that really is valuable to your day-to-day life, because I think that it's important to realize that your end users always want more than what they have right now. You need to just accept it. And you need to build systems flexible enough and advanced enough that could handle what users need. You don't want to disappoint your users, especially because there are so many other ways how systems could be built rather than Oracle. So if we have all of these powerful tools, we should be using it. We should be making Oracle systems really, really cool because it's free. Everything that I showed you, it's no additional licenses. It's built in the engine. And SQL together with PL SQL is the most powerful combination of any database development platform because SQL itself is not a silver bullet. Sometimes you need to step out of it. Sometimes you need to make system do more than it is right now capable of. And something to really back to my learning importance, you cannot use 20-year-old books or even my own 20-year-old presentation or my dear friend Stephen Feuerstein's book or anything that is from version 10 or from version 9. You constantly need to learn, you constantly need to make sure that your knowledge is up to date because there are new, cool, and powerful solutions. But on the other side, you need to recognize that those cool and powerful solutions bear responsibility. You need to check everything, you need to learn. You shouldn't go to the chat GPT, get a code snippet and stuff it into your code environment. You need to really understand what's going on inside if you or your manager doesn't want to appear on the front page of New York Post. You need to know how this functionality works. You need to know what happens. You need to know what's inside of that black box. Okay, here is my information, email. There is some materials on Dalcian website. I sometimes, if I remember about it, do blog posts, and some books here are still reasonably useful, especially the performance tuning tips and techniques. This is 11, 12, and still a lot of those tips are reasonable, even if it's a 10-year-old. Still, it is useful. Okay, thanks a lot. Thanks a lot one more time to Viscosity and to Coleman. I really appreciate everybody being part of this presentation and being part of New York Oracle user group community. So let's see if I have any more questions.
You've got a lot of very kind words in the Q&A as well.
Yes. Yeah. I think I have a feeling that list AG with 4,000 characters had been in pain in various body parts for a lot of developers. Yeah, so I can definitely understand there is a way to kind of Oracle finally made it smart enough so it would not just blow up. But also only if you are, if I correctly remember, 21, but you may need to check. Kind of in anyways, I still prefer my own CLab approach if needed. If I know that it could go to around 4,000 characters, I use my own. Okay, so that's pretty much summary. And yeah, books are fun. Books are important, and it's an interesting way of learning because now everybody would just go to ChatGPT and start doing the basic research. I still think that people need to research more rather than just copy pasting, because like a couple of weeks ago we've been bitten by one of my developers read something via ChatGPT and panicked. It took me about 10 minutes to realize that ChatGPT incorrectly parsed one of the Oracle documents and provided the results that was less than what Oracle documents were expecting you to understand. Maybe I will write a blog post about it a bit later. So you can get a lot of strange results unless you really look at the original documentation. So my strong recommendation is follow the logic, follow the leads. Okay, any more questions, comments, life universe? Yeah, I don't see anything else. So
All right.
okay, maybe we give it a
Oh,
minute.
you have so many sweet messages, Michael. It's a very great crowd today. Thank you guys so much for joining us. Again, it is recorded, so give us a day or so to get that posted, and then just check out in your email how to access it, where to access it, etc. But yep, we'll grab slide decks or whatever Michael has for us today to share with you. And yeah, you've got his contact information here on the screen, so please grab a screenshot of that if you're interested in reaching out or checking out his awesome blogs. Awesome. All right. So if that's it, thank you so much, Michael. Coleman, Rob,
Sure.
thank you guys too. And we hope to see you guys again. Michael, we are going to be booking you again. I know we've got a couple abstracts from you that I think everyone here would love to see, and we are excited to get those on the calendar this year. So I will see you at Kscope and
Definitely.
hopefully others here too.
Yeah, Kscope should be fun. It will be a really interesting community. It's lively, it's energetic, and
Yeah.
it's just fun.
It is such a fun conference. And if anyone wants to stop by my booth, I'll probably have Michael come by and play some music for us because he's a phenomenal musician. And last year we had
Yeah,
a
in Nashville, we had a real music jam there.
yes, it was amazing. One of my colleagues also plays the guitar and brought a portable electric guitar for us, and we plugged that bad boy in and we just jammed. It was so much fun. Oh, but yes, awesome. Always a great time with you. And thank you again for your expertise. So we hope to see everyone soon, whether it's virtual or in person. And I hope everyone has a great day.
Thank you, everybody, again from NYOUG.
Great. Thank you.
Thanks,
Thank
Michael.
you.
Bye.